Hello, I am going to finish off the Edexcel Chemistry Paper Unit 1 Higher for 2017. So we're on question 4. We got to question 4. So, question 4a, part 1. Most metals are extracted from rocks found in the Earth's crust. Iron is extracted from iron oxide. The iron oxide, Fe2O3, is heated with carbon. Complete the balancing of the equation for this reaction by putting numbers in the spaces provided. So we have 2 Fe2O3 plus 3C arrow something Fe plus something CO2. Have a go at balancing that equation. Right, so the answer is 4 Fe and 3 CO2. The answer being there are 4 ions because the big 2 times the little 2 makes 4, and there needs to be 3 CO2, so 3 CO2 means 3 carbons because there's no number by carbon, that means 1. 3 times 1 is 3, and then for the oxygen there's a little 2, 3 times 2 is 6. We come over here, there's O3 and a big 2. 2 times 3 is 6, and then the big 3 is the carbon. The examiner's report says it was very well answered. They were able to do 4 and 3. The most common error was 2 and 3, which makes sense because they were just balancing the big numbers. Complete the sentence by putting the X in the box in your answer. When iron oxide reacts with carbon to form iron and carbon dioxide, carbon is reduced and iron oxide is reduced. Carbon is oxidized and iron oxide is oxidized. Carbon is reduced and iron oxide is oxidized. Carbon is oxidized and iron oxide is reduced. The answer is D. The carbon is gaining oxygen, that is oxidation. The iron is losing oxygen, that is reduction. That doesn't have emotes because it's just a multiple choice. Right, question 4b. Gold is used to make some items of jewellery. Gold alloys, rather than pure gold, are often used in items of jewellery. The table shows some information about the properties of 2 types of gold. So we have 18 karat gold with medium strength and costs £16 per gram, and 24 karat gold with low strength and costs £22 per gram. Use the information in the table to explain why gold alloys, rather than pure gold, are often used in items of jewellery. So, in case you don't know, gold is measured in carats, where 24 is pretty much pure gold, and anything less than 24 is not pure. So 18 karat gold is the alloy and 24 karat gold is the pure gold. Off you go. Right, so the 2 marks are for, my help gave you the answer. 24 karat gold is pure, 18 karat is the alloy. The alloy is stronger. If you notice the underlining which means you've got to say it's more strong than pure gold. We're not saying it's just strong, we're saying it's more strong than the pure gold, because the pure gold is quite strong anyway. Less easily damaged, worn away, bent out of shape, less malleable, withstand forces. Alloy is cheaper. You've got to have cheaper, as in relatively to the pure gold, it's cheap. Okay, not necessarily actually cheap, but compared to the pure gold, it's cheap. Most candidates scored 4 marks by reference to the fact that the gold alloy is both stronger and cheaper than pure gold, or by the reverse argument, as in pure gold is more expensive and weaker. Many candidates did go into unnecessary detail regarding the structure of alloys, which is not asked in the question. Very few candidates identified the alloy as 18 karat gold or pure gold as 24 karat. So this is another example of not stating the obvious. Or you should state the obvious, just in case it gets you a mark. So in nowhere in this question is it said that pure gold is 24 carats and the alloy is 18 carats. So that is information in the table. So if you've got this glaringly obvious piece of information that isn't given you in the question, you might as well write it down just on the off chance that it's worth it. Occasionally, properties of gold not mentioned in the table were discussed. It clearly mentions in the question that information in the table needs to be used. Okay, so that's about reading the question. So that's people wasting their own time. 4C. The table shows 4 metals in the order in which they appear in the reactivity series from most reactive to least reactive. The methods of extraction for 3 of these metals from their ores are given. So we have sodium, no method of extraction given, aluminium, electrolysis for extraction, iron is heated with carbon to extract, and gold is found uncombined when you extract it. Suggest a method to extract sodium from its ore. 1. Right, the answer is electrolysis. Right, I was going to explain why this method is used, but I won't because that's the next question. Majority of candidates can correctly identify the method of sodium as electrolysis. The most commonly incorrect answer is heating with carbon. There we go. Explain why this method has to be used. 2 marks. Right, the reason is sodium compounds are very stable. Sodium is very reactive. You could say sodium is more reactive than aluminium. Electrolysis is a powerful method of extraction. Aluminium is extracted by electrolysis, so sodium must be extracted by electrolysis because sodium is higher than aluminium. Carbon does not react with sodium compounds. So there you go. Most candidates scored just 1 of the 2 marks available by reference to the fact that sodium is more reactive than carbon. A few candidates were able to score 2 marks by reference to sodium being more reactive than carbon or aluminium, coupled with the fact that electrolysis is more powerful or stronger method of extraction. Very few referred to reduction or made use of the information about aluminium in their response. Common errors. Most candidates were able to make a comparison of the relative reactivity, but were unable to give the reason why electrolysis is used. The question is analogous to questions from previous exam series, but most candidates were unable to explain why electrolysis is used, namely that it is a more powerful method of reduction. So yes, so there are 3 ways of extracting metal. So with gold, silver and platinum, you find them uncombined. They haven't reacted with anything, so you can just find them. With any metal above silver in the reactivity series but lower than carbon, you extract it by reacting with carbon. So the carbon takes the oxygen away. And the reason you use carbon is because it's cheap and plentiful. And any metal above carbon has to be electrolysis. 4D. Shape memory alloy tubes can be used in modern surgery as stents to repair damaged blood vessels. Explain what is meant by a shape memory alloy. Off you go. Right. Explanation including the alloy returns to its original shape with a change in temperature or electric current. Did people get that? It was well answered. Answer directly linked to the example in the question. Returning to the original shape through heating. Common errors. Although the word remember shape was used in many responses, it is not credit worthy. So you can't say it remembers its shape. If you say they return to the original shape, it only gets 1 mark because there's no reference to heat or current. Some responses were completely wrong and showed that the shape could not be changed when formed, or alloys simply took the shape of their environment. I think those people are confusing shape memory alloys with thermosetting plastics. There we go. Right, on to question 5, which is about fuels. Crude oil is fractionally distilled to produce fractions. These fractions have many uses. Complete the sentence by putting a cross in the next answer. The fraction least likely to be used as a fuel is A. Bitumen, B. Diesel oil, C. Kerosene, D. Gases. The answer is bitumen, because it's the one with the largest number of carbons, least likely to burn. Right, there's no exam mistake there. Some of the fractions from crude oil are cracked. Describe what is meant by cracking. Off you go, 2 marks. Cracking is the thermal decomposition of large hydrocarbon molecules, that's 1 mark, to form shorter molecules or alkenes. What did you get? Well answered. Most candidates scored 2. In many cases, when 1 mark was scored, it was for the correct reference to the first marking point, namely decomposition. However, the second marking point was not gained because you didn't say short hydrocarbon or alkanes or alkenes. In many cases, Cracking was confused with fractional distillation. Well, that is a classic mistake people make. You need to remember, cracking is breaking down of big alkanes into smaller alkanes and alkenes. Fractional distillation is separating different sized alkanes. Cracking is a chemical reaction. Fractional distillation is a separation technique. Question 5b, part 2. When butane is cracked, a number of different hydrocarbons are formed. Draw the structure of a molecule of one of these hydrocarbons showing all bonds. 2 marks, off you go. So you could have drawn methane, CH4, ethene, C2H4, ethane, C2H6, propene, C3H6, propane, C3H8, butene, C4H8, correct number of hydrogen carbons, and the correct bonds. Gets you the marks. What do we get? It was generally well answered. Mainly methane, ethane, or ethene. 1 mark was scored for correct reference to the first marking point, namely the structure, so the bonds was wrong. In a few cases, 1 mark was scored for repeating units of polymers. Scoring 1 mark because they have the correct number of carbon and hydrogen atoms. In many cases, they're apparent from the response that candidates misread the question and drew the structure of butane. A surprising number of candidates showed the symbol B for boron instead of C for carbon, representing butane. Many incorrect answers had hydrogen and carbon the wrong way around. There we go. So yeah, some people were confusing cracking with polymerization there. So all these methods with hydrocarbons, you need to make sure they're clear in your head. 6 mark question. Following passages give some information about hydrogen used as a fuel in cars. The fuel used in some cars is hydrogen. It is stored in pressurized tanks underneath the cars. The process is used to produce hydrogen, and pressurize it may require the use of fossil fuels. The company expects sales of these cars to increase as more hydrogen filling stations are built. Use your knowledge of hydrogen and petrol to explain the advantages and disadvantages of using hydrogen rather than petrol in fuel cars. So classic comparing two fuels. Off you go. Right. So to get 6 marks, you need a detailed explanation of at least an advantage and a disadvantage of both. The answer communicates ideas clearly and coherently, uses a range of scientific terminology. Spelling, punctuation, and grammar are accurate. So, advantages of hydrogen. Only water is produced. Water is harmless. No carbon dioxide is emitted. Less greenhouse gas. No carbon monoxide is emitted. Carbon monoxide is toxic. No oxides of nitrogen, sulfur dioxide emitted. Doesn't release toxic gases. Doesn't contribute to acid rain. Water is renewable or sustainable. Plentiful supply of water. The product of combustion is more hydrogen fueled. Raw material water for fuel is renewable. Okay. So it's good to remember your pollutants work. Pollutants always comes up. Disadvantages. Hydrogen is more difficult to store or transport. Hydrogen needs storing or transporting in pressurized or air tanks. Hydrogen may be produced by electrolysis, using electricity made from fossil fuels, which is costly. Carbon dioxide will be produced in the manufacture of it. So when you burn the hydrogen, you don't make carbon dioxide, but when you make the hydrogen to burn, then you're producing carbon dioxide, because the fuels you're burning for the electrolysis are probably fossil fuels, as the question had. Carbon dioxide will be produced in the manufacture or transportation. More greenhouse gas emissions. Hydrogen is less available on the market. And there are fewer hydrogen filling stations. It is costly to convert them, existing stations. Hydrogen cars are more expensive to run. Cars made to use hydrogen are more expensive than cars that use petrol. Hydrogen is a gas or explosive when mixed with oxygen. Leaks are difficult to detect. So there you go, there's the list of them. So you need to give advantages and disadvantages, be coherent, and use correct spelling, punctuation, and grammar. Right, how was this answered? It was challenging, but we're able to access it. So you need to explain advantage and disadvantage. So yes. Problems with this question. Many candidates identified advantages and disadvantages but not explain them. So that means level 2 is the maximum they could get, so 2 marks. So with 6 mark questions, it's not 1 point gets you a mark. You have to do a certain number of things to get to levels 1, 2 or 3. So level 1 gets you 2 points maximum, level 2 gets you 4, level 3 gets you 6. So in this case, if you wrote 6 advantages, you would only get 2 marks because you didn't write any disadvantages. Some candidates gave account of advantages or disadvantages on petrol, not hydrogen. Most candidates identified water as a product of combustion or renewable fuel as advantages without explaining them. Most candidates identified storing under pressure or production by electrolysis of water as disadvantages without further explanation. In some cases, candidates confused hydrogen with biofuels. Another typical misconception was that hydrogen is renewable because it is abundant in the air. Well, hydrogen is not in the air, and it's a good job it isn't because it's flammable. Nitrogen is abundant in the air. Right, let's move on to the last question. Question 6. Rocks. Calcium carbonate is an important raw material in the chemical industry. Which of those is not made in the process using calcium carbonate? Put across. Is it A, cement, B, concrete, C, glass, or B, PVC? The answer is PVC. Probably no examiner's notes for that. No. Question B. The diagram shows reactions of calcium compounds. So you have calcium carbonate, CaCO3. If you do step A, you make calcium oxide, CaO. If you do step B, the calcium oxide turns into calcium hydroxide solution, lime water, CaOH in brackets 2. And if you do step C, the lime water turns back into calcium carbonate. So it's a cycle. 6b part A. In step A, a known mass of calcium carbonate is heated in order to obtain calcium oxide. The mass of calcium oxide formed is found. Suggest how to continue the experiment to prove that the reaction is complete. Go. Right, you do reheat the solid, reweigh the solid. If the mass remains the same, then it's fine. Okay? It was generally well answered. Misconceptions were many candidates incorrectly emitted. Sorry, wrong one. Misconceptions. It would appear that it was poorly answered actually. They were able to score the 3 marks. It's quite a difficult question to think through. So basically, what you're trying to say is, you know the reaction's finished when you don't lose any more mass. Some candidates were thought they'd been asked if the reaction proceeded at all, so many suggested adding water to see if there was a reaction to produce calcium hydroxide. Many candidates misunderstood the question and thought the experiment was about investigating conservation of mass. Most candidates omitted the need to reheat the calcium oxide but described the test for carbon dioxide and gave the wrong inference about the presence of carbon dioxide, indicating the reaction is complete instead of the absence of carbon dioxide. So there you go. The reaction in step C is one that occurs as a test for carbon dioxide. Write a balanced equation for the reaction of calcium hydroxide with carbon dioxide. Well, at least you have the formula for calcium hydroxide and you have the formula for calcium carbonate, and you should know the formula for carbon dioxide is CO2, so it should be quite straightforward. Off you go. The answer is CaOH in brackets 2, outside the brackets, plus CO2, arrow CaCO3 plus H2O. This was well answered. Problems. Many candidates omitted H2O as one of the products. Many candidates attempted to balance the formula, so in this case you don't need any numbers. Several candidates gave word equations, despite the question clearly asking for a balanced equation. Many candidates were careless about writing formulas, so they wrote CO2 with a lowercase o, or H2O. I'm not sure. I think that must be a typo because H2O is actually correctly written there. But just make sure you know which symbols should be lowercase and which should be capital. And there should be no excuse because you get a periodic table in the exam, so it would take literally 1 second to look at the element to know what should be capital, what should be lowercase. Okay, question 6c. The diagram shows where the following rock can be formed from the Earth's crust: limestone, a sedimentary rock; marble and metamorphic rock, basalt, an igneous rock consisting of small crystals, granite, and igneous rock consisting of large crystals. There's granite at the bottom, then there's a layer of marble, then there's a layer of limestone, then there's soil and basalts at the top because it comes up through a hole in the middle. Explain how these rocks were formed. 6 marks. Last question. It's another 6 marker. Right, so you need to talk about how all 4 rocks were formed to get to level 3. To get to level 1, you talk about 1 of the rocks. To get to level 2, you talk about 3 of the rocks. So, igneous basalt is made from lava, is forced up, cools quickly to form small crystals. You have to say quickly and small because the size of the crystals depends on how quickly it cools, and granite cools slowly to form large ones. It solidifies at the surface. Granite is made of magma, not lava, because lava is when it goes to the surface. Magma is when it stays underground. It's forced up. It cools slowly to form large crystals, so you have to say slowly and large. Solidifies under the ground. And then granite is intrusive, which means it is in the ground, and basalt is extrusive, which means it's out the ground. Right, the sedimentary rocks. Limestone is formed from layers, you've got to say layers, of sediments and or seashells. Sediments fall to the bottom of the sea. Over a long time period, they are compacted or squashed by pressure. The particles are cemented together. Metamorphic rocks. Limestone is changed by heat from magma and pressure from the rocks above and buried deep below. So you have to do a detailed explanation of 4 rocks. You communicate the idea coherently and uses scientific terminology. It was quite straightforward, yeah, because it was like you were describing 4 things basically. So this could have been 4 separate description questions. Most common detailed explanations for granite and basalts. With statements about metamorphic rock, which got level 2. Fewer candidates explain the formation of metamorphic rock in detail. If they did it with reference to limestone, oh dear, not marble, and sources of heat and pressure. Oh, for reference to limestone, which you would do for metamorphic. The most common route for level 3 was detailed explanations of granite, basalt, and sedimentary rock formations, with metamorphic rock explained in less detail. In some cases, there was confusion on the formation of sedimentary rock with metamorphic rock, some responses incorrectly referring to formation of sedimentary rock requiring both heat and pressure. So you don't need heat for sedimentary rocks, you just need pressure. So to improve, candidates read all the information in the questions carefully and use it to help them answer the questions. Learn key definitions for key processes such as electrolysis and cracking. Ensure the formulae, especially in balanced equations, are written carefully with particular emphasis on correctly writing upper and lowercase symbols in formulae, coupled with correctly subscripted numbers. Practice writing the names of common polymers highlighted in the specification. Understand what is meant by heating to a constant mass to prove that a reaction is complete, such as in the thermal decomposition reactions of metal carbonates. With extended writing questions, check their responses to ensure that when a point has been made, it's been linked to an explanation if necessary. So that's about it. That's it for the paper. So there we go. So I hope this helps. I'm going to do some more papers later on, so have a good evening.